So we'll be looking at calculus questions. We'll start with the product rule, the quotient rule, then also look at the chain rule. Also be taking some examples based on what you wrote in the exam. But we'll start with the flow sheet questions first. Okay, so let's start with the part 2, weights in differential calculus, not limits, but differential calculus. So we'll start with question, let's start from the beginning, question 1. So how can we differentiate those two? So differentiate the following functions of x using the first principle. So question 1a, the question is y is equals to 1 over x plus 2, using the first principle. So the first thing we're going to do is, we have the function of y. Now this function of y is the same as the function f of x. So what we need is the function f of x plus h. What does this mean? Where there's x, replace with x plus h. Where there's this x, replace with what? X plus h. So to have 1 over x plus h plus 2. Like that. That's the same thing. Where there's x, replace with x plus h. Now, the formula for the first principle, dy dx is equals to the limit as h approaches 0 of f of x plus h minus f of x divided by h, like that. Then from there, let's do the substitution. So this will be equals to the limit as h approaches 0. Where there's f of x plus h, we put that function, which is 1 over x plus h plus 2 minus f of x, which is 1 over x plus 2. Everything is divided by h, like that. So now we need to subtract these two. So we shall do it like this. The limit as h approaches 0, we're focusing on what is on top. So the LCM of the two will be x plus h plus 2 and x plus 2. So if this goes into this, we get this. This times 1, we get x plus 2. Minus this into this, we get this bracket. This bracket times 1, we get x plus h plus 2. Remember, there's this h, so we can say divided by the same h. We haven't used it yet. I hope that's okay. So now in the numerator, let's open the bracket. We can say the limit as h approaches 0. Let's open the bracket. We'll have x plus 2 minus x minus h minus 2. This negative multiplies everything. Now the whole thing is divided by x plus h plus 2 brackets x plus 2 multiplied by the reciprocal. Remember, divide by the same as the reciprocal, like that, multiplication. The x and the x can cancel. The 2 and the 2 can cancel. what do we remain with? Limit as h approaches 0. So we just have negative h. That's the only thing remaining here. Everything has cancelled. Divided by this guy, which is x plus h plus 2 in brackets, x plus 2. Remember, we're multiplying by h, like that. So the h and the h can cancel. One is numerator, one is denominator. These two can cancel. What do we remain with? Limit as h approaches 0. We just have negative 1 divided by x plus h plus 2, x plus 2. Now we can apply the limit. So applying the limit, this is what we obtain. Where there's h, we replace it what? 0. What do we get? Negative 1 divided by x plus 2, x plus 2. Well, this is just a 0, so we just remain with x plus 2. So now x plus 2, they're the same. Put them together, give you a squared. So divide x. Divide x is equals to negative 1 divided by x plus 2 in brackets squared. That's it. Any questions on that one? I hope it's okay. Okay. Hurry up, hurry up, hurry up. Okay, so we're still on the same question. We're going to part B now. Part B, which is y is equals to of x. Okay, so the next question is y is equals to, what's part B? Y is equals to the square root of x. Now remember, we're using first principle. So since we're using first principle, what we need is f of x, which is just the same as y. So f of x is equals to root x. Then f of x plus h is equals to, so where there's x, we replace with x plus h. So we have something like this. Question 1 part B, yes. On differential calculus, not limits. So we bring in the formula. dy dx is equals to the limit as h approaches 0, f of x plus h minus f of x divided by h, like that. Then we do our substitutions. So this is equals to the limit as h approaches 0. Here where there's f of x plus h, we're going to put the square root of x plus h minus, where there's f of x, we shall put the root of x. Everything divided by h. Now, for the previous one, we had to add the two fractions and proceed, but for this one, we don't have fractions. So, instead, what we do for this one is we're going to rationalize. So let me even write it here. We rationalize. Now, to rationalize, this is what it means. So we have the limit as h approaches 0, the root of x plus h minus the root of x over h. To rationalize simply means multiply both the denominator and the numerator by the conjugate of this. Now, what's the conjugate? The conjugate is just the same thing, but where there's negative, we just put a plus. So x plus h plus root x. So if you're rationalizing, then there's a positive here, meaning that what you have there will be what? A negative. So it's just the opposite. Now you multiply both denominator and numerator by the conjugate. The same conjugate, which is the one which has a plus. Now the concept we're going to use for the numerator, you can see that they are the same. The only difference is that one is a minus, one is a plus. We're going to use the difference of two squares. Remember, a plus b in brackets, a minus b in brackets is the same as what? A squared minus b squared. Difference of two squares. So we have there, these two are multiplying, remember? We have the plus and the minus. So let's apply the difference of two squares. So limit as h approaches 0. So the first part, this is representing a, this is representing b. So for the first part, we're saying a squared, meaning that we have this guy squared, which is root x plus h in brackets squared minus root x in brackets as well squared, and between the two is a minus. Denominator, what we have? We just have h multiplying with this, which is the root of x plus h plus the root of x. like that. So what next? We know that the square root and the square will cancel out. So let's see how it proceeds. So if the square root and the square cancels out, what we get? We have the limit as h approaches 0. We have x plus h minus x. So the square root cancels the square, x plus h. Square root cancels the square, x, divided by this whole thing, which is h, open bracket, root x plus h minus root, like that. I hope that's fine. What will happen in the numerator? The x and the x will cancel. One is positive, one is negative. It's a positive, yeah. Thank you. So this x and this x will cancel. What do we remain with? Limits as h approaches 0. So we just have h over h, open bracket, the root of x plus h plus the root of x, like that. What next? The h and the h will cancel. So this will cancel, this cancels, just remains 1. So limit as h approaches 0, 1 over x plus h plus x. Now things are simplified. So now we can apply the limit. The question is, why can't we apply the limit here? Because we have a 0 in the denominator. And once you have a 0 in the denominator, it's not simplifiable, I would say. Now we can apply the limit. Where there's h, let's replace with the 0. What do we get? So dy dx is equals to, after you apply the limit, you will stop writing this part, so that you just have 1 divided by root x plus root x. Remember, it's x plus 0, which is just x. That's why we just have x there. So this is equals to 1 over, there are 2 of them, so 2 root x. So that's your final answer, 1 over 2 root x. Yes. Oh, what do you mean when applying the limit? Well, what I mean is this. This h that you see here, if I replace it with 0, the whole thing will be 0. And you can't divide by 0. So you have to manipulate it such that the h cancels, then you don't have it here. But if you put it here, the whole thing won't be 0. That's the difference. So since in this case, the whole thing is not 0, that's why we have a value. But if you replace it there, the whole thing will be 0. Which one? The what? Which 2x? These two?
2 squared with x.
Coming from this. What is x plus x? X plus x is 2x. So this plus this is 2 of this. Okay. We're still in the same tutorial sheet. Let's look at question 2. Quotient rule. Quotient rule is used when two functions are dividing. Product rule is used when two functions are multiplying. That's the difference. So you have to know your formulas. Let me just give you the list of the formulas that you need to know. Then we'll be looking at questions that we'll be rehearsing. So to start with, the first one is our first principle. These are just the formulas. First principle, we can just write them down. So first principle, dy dx is equals to the limit as h approaches 0, f of x plus h minus f of x. Everything is over h. First principle. The second one, let's talk about the chain rule. So for the chain rule, I'll give a brief example first. I'll say if y, for example, is equals to x plus maybe x squared. Let me say x plus c power n. Is that okay? Yeah. So, yes. Which one? The first one? First principle is. So it's also known as the delta method. So it's the one that we're doing, where we're supposed to find f of x plus h and f of x then divided by h. The chain rule is used when you have a, what's this, a function which is in the brackets with a certain power n. That's when you use the chain rule. So dy dx for the chain rule will be equals to dy dx. Will be equals to dy du multiplied by du dx. We'll take an example so that you understand it. For now, I just want you to write them down. The next one is the product rule. Product rule. So product rule, this one is used when two functions are multiplying. For example, if the function y is equals to u times v, meaning that the function u is multiplying with the function v. So if these two are multiplying, then dy dx will be equals to uv prime plus vu prime. When you say v prime, you simply mean v differentiation. Differentiated. When you say u prime, it's u when it has been differentiated. So that's the formula. The next one is the quotient. Quotient rule. So for this one, it is used when two functions are dividing. Two functions are dividing, use the quotient rule. So dy dx in this case will be equals to vu prime minus uv prime divided by v squared. Okay, I want you to understand when to use these. Sometimes you won't be told. Two functions multiplying, product. Two functions dividing. When we say two functions dividing, we mean maybe, for example, you have 2x over maybe sine x. These are two functions dividing. When you have a function in a bracket, you use the chain. For the first principle, they'll specify. This is what I want you to do. I know you have the paper, the one that you wrote for mathematics. I want you to open it. Let's take an example from there. Find it, find it. Section A, question 7. Question A, sorry, section A, question 7. I want you to tell me which rule, which formula we're using for that question. Have you found it? Section A, question 7. The question says, given that y is equals to that, find dy dx. So the question is, y is equals to x squared ln 2x divided by e to the x squared plus 1. Find dy dx. How many marks? 5 marks. The question is, which method did we use? Anyone to try? Yes. Quotient. Are you sure? You're not sure. Okay. Anyone who's sure? So yes, we use the quotient, but in the process of using the quotient, we'll use the product. Because look at this. In as much as the two functions are dividing, these two functions are multiplying. So we'll use the quotient, but in the process of using the quotient, at some point we'll also use the product. So let's do that. Okay, so remember, for product rule, for quotient rule rather, you have two functions multiplying. So the one in the numerator is u, the one in the denominator is what? V. So what is our u in this case? Our u is x squared ln 2x, like that. What is our v? Our v is e to the x, x squared plus 1. Understand that we're using two methods. We're using the quotient rule, that's the general rule we're using because the two functions are dividing. So whatever is on top is our u, whatever is down there is our v. So what do we need? We need u prime. Now what is u prime? U prime simply means we need to differentiate the function u. So now, how do we find u prime? Since these two are multiplying, meaning that now we have to use the product rule. Are we together so far? Okay. So since we need to use the product rule, let's see how we do it here. Let me do this. So for the product rule, this part, our u is what? X squared. Our v is ln 2x. What is the derivative here? U prime, 2x. What's the derivative here? V prime. So v prime should be 1 over 2x, I believe. Is it? Differentiate that, get 1 over. So differentiate this, we get a 2, supposed to be 2. 2 over 2x. So now that we've differentiated that part, let's apply the product rule. So applying the product rule, this is what we're going to get. Product rule is given by u v prime plus v u prime. What is u? U is x squared. What is v prime? V prime is 1 over x. Remember, the 2 and the 2 just cancel. Plus, what is v? Ln 2x. What is u prime? U prime is 2x, like that. This x and this x will cancel, leaving us with what? X plus 2x multiplied by ln 2x. Now, what does this represent? This represents the derivative of u, which we found by using the product rule. So all this that we have here will come here. X plus 2x ln 2x. Like that. Are we lost or we're together? We are lost. Where are we lost? This one? So we understand how this came about? Is this okay? Or we have forgotten? We have forgotten rather. Have we forgotten? You have forgotten? Okay, let me remind you, if you have forgotten 2x power 3, how do we differentiate? Power times coefficient, what do we get? 6. From the power, subtract 1, what remains? 2. Now you remember. So here what is happening? 2 times 1, what do we get? 2. From the power, subtract 1, what remains? 1. I hope we're back together now. Now, let me start from the beginning. Why are we doing all this? Remember, the two functions are dividing. There's u and there's v. So now, the u, we've written it down, is this guy. The v is this guy. So we need to find the derivative for u, which is given by these two functions, which are multiplying. So since these two functions are multiplying, to find the derivative, we have to go through the product. That's the one which involves two functions multiplying. So now that side we have v. Since we have v, we need to differentiate. Now, differentiating this again, we need to go through the product rule. So the first function is e to the x. The second function is x squared plus 1. Then what is u prime? What's the derivative of e to the x? What is the derivative of e to the x? Anyone to try? No. You have forgotten. What's the derivative? Almost there. What's the derivative? This guy doesn't change. So the derivative is e to the x. So v prime, what's the derivative of 2x? We say it's 2 times 1, which is 2. From the power, we subtract 1, so we remain with what? X. 1 is a constant. Derivative of a constant, 0. So the 1 disappears. Now, we are applying the product rule, which is this formula that we have here, which is u v prime plus v u prime. What is u into the x? What is v prime? 2x. What is v? X squared plus 1. And what is u prime? E to the x. Like that. Now, if you look at what we have here, you can see that e to the x is common. So let's just factor it out. So e to the x is common. What remains? 2x plus x squared plus 1. Just factor out e to the x. And everything else remains inside. Now, what we have there is the derivative of v. So v prime will be equals to e to the x, open bracket, x squared plus 2x plus 1. Like that. Okay, let's bring it here now. We're not done. From what I've seen, the topic which was dominant in that paper was matrices. We had a lot of them. So you have to go. We have to go through a lot of matrices as well. Okay, so now we have u, we have v, we have u prime, we have v prime. Let's apply the quotient rule. Remember, dy dx quotient rule is equals to, we said vu prime minus uv prime divided by v squared. So it's just a matter of substituting now. What is v? V is e to the x, in bracket, x squared plus 1. What is u prime? U prime is this guy here. Yes. So what is u? We have x plus 2x ln 2x minus, what is u? X squared ln 2x. What is v prime? V prime is this guy, which is e to the x, open bracket, again, we have 2x plus x squared plus a 1. Now everything is over v squared. What is v? V is e to the x squared plus 1 squared. So once you have these four, this part is just a matter of substituting. Just substitute. That's it. Looks messy. So in the numerator, let's factor out e to the x. What remains? So we'll have x squared plus 1 brackets. Here we have x plus 2x ln 2x minus, here what remains? We have x squared ln 2x, open bracket, 2x plus x squared plus 1. Remember, the e to the x and the e to the x has been factored out. The whole thing is divided by e to the x squared, x squared plus 1 squared, because the square will affect both. So your last step, you just cancel out the e to the x and 1 e to the x, because remember, you can cancel these two. So this will go, here you just remain with 1, because it's a square, so you just remain with 1, then it's the final answer. 5 marks. Any questions on that one? This side? This side is basically just replacing. So our V, which is this guy, is this one here. We have our U prime, which is this guy, which is the whole bracket. Our U, which is this guy, this one here. Our V prime, which is this one, is this whole guy. So now what we did here is, there's e to the x here, then there's e to the x there. So I just factor out e to the x and write down what remains, which is this part. Same thing, I just move e to the x, write down what remains, which is this part. Then I said e to the x and one of these, because there are two of them, one of these can just cancel. And that's your answer. Okay, let's go to section B, question 11. No, the exam paper. Question B11. So question 11 has, is it 4 questions? You're supposed to choose 2. Which ones would you choose amongst those 4 questions? 10, 11, 12, 13. No, the exam paper. And they made sure that for each question, there's at least one question that will give you hell. And that question has 8 marks for each of those. So let's do question 11, part B. It's under limits and continuity, still calculus. Let's see how we can simplify it. The question says, discuss the continuity of the function f described by that expression that we have. Questions on continuity are 3 marks, my people, very 3 marks. I'll show you how simple they are. 8 marks for free. So discuss, when they say discuss the continuity, they're saying determine whether the function is continuous or not, in simple terms. So the question is f of x is equals to the piecewise function. So we have x minus 2. We have root x minus root 2. Here we have 4 over root 2. I remember doing this question yesterday. X is equals to 2. Okay. So discuss the continuity of the function, that one. And then it looks like that. Before we go further, any idea on what we're supposed to do? The question has 8 marks. And like I said, those 8 marks are free. Any idea on what we're supposed to do? Okay, so the function f of x is equals to 2 things. F of x is equals to this. F of x is equals to this. So let's write them. f of x is equals to x minus 2 over root x minus root 2. Also, f of x is equals to 4 over root 2. This is what we have. So to solve this question, all you need to do is you need to find the limit. And by finding the limit, this is what we mean. This one, which is f of x is equal to this function, we're going to say the limit, or we can say f of x is okay, is equal to the limit of the same function as x approaches 2. So as x approaches 0, as x approaches 2, of the function f of x, like this. Don't get confused. F of x is equal to this guy, f of x is equal to this guy. So now we're saying find the limit of f of x as x approaches 2. Now, what is f of x? This function here. So this is equals to limit as x, why am I writing it? As x approaches 2, write down the function x minus 2 divided by root x minus root 2. Like that. Okay, so here's the part that they thought would be very confusing for you guys. So the part is that you need to know that x is the same as this. Do we agree? X is the same as root x squared. Is it the same? Why is it the same? Because the square root and the square will cancel, right? This simply means that 2 as well can be written as 2 like this. Same thing, right? Let's replace those guys with these two. So this is what will happen. We'll have limit as x approaches 2. Here where there's x, let's put the root of x in brackets squared. Minus where there's 2, let's put the root of 2 in brackets squared. So root x minus root 2. Nothing has changed, right? We say that x is the same as this, 2 is the same as this. Now, again, remember this, a minus b is equals to a plus b, a minus b. The difference of two squares, right? So the two squares, what we have in this case are what? Root x and the root 2. So now we want to change it from this form, square, 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 to this form, plus and minus. How does that change? We'll have the limit as x approaches 2. What do we get? Help me. What do we get? Apply the difference of two squares. What do we get? I want the plus and the minus. What do we get? Not x. Square root of x, right? So it will be square root of x plus square root of 2. In brackets, what else? Square root of x minus square root of 2. Remember, it's the whole bracket squared, the whole bracket squared. This whole bracket is representing what? A. The whole bracket is representing what? B. This is divided by what? Root x minus root 2. The minus can cancel. This whole thing can cancel that. Simple as that. What do we remain with? The limit as x approaches 2, root x plus root 2. Now, let's apply the limit. Let's apply the limit. To apply the limit, we simply say we replace x with 2. What do we get? Root 2 plus root 2. What is root 2 plus root 2? 2 root 2. Like that. Then now we have to rationalize. Remember rationalization where we said multiply both denominator and numerator. This time around we'll say multiply by root 2 and root 2, like that. This is rationalization. Let me write it here. This is the process of rationalization. Multiply both the numerator and the denominator by root 2. So what do we get? We have a 2, root 2 times root 2, we just multiply what is inside, hence we get root 4 over root 2, like that. What's the square root of 4? 2. So, numerator we have 2 times 2 over the root of 2. 2 times 2, 4 over the root of 2. Now this is the same as this. Since we've managed to prove that using limits we get this value, then the conclusion is that the function is continuous at x is equal to 2. So let me put the conclusion here. We can say since the limit as x approaches 2 of f of x is equals to, is that true? Put the 2 there. Okay, it's fine. Is equals to 4 over root 2. Then the function is continuous. Continuous at x is equals to 2. Because it said discuss. So since we're discussing, we need to give a conclusion. So since the limit is the same as this function, the conclusion is that it is continuous at x is equals to 2. Okay, let's go back to the tutorial sheet. Let's go through limits question now. Tutorial sheet for calculus. Okay, so from the tutorial sheet, let's do question. Let's start with question 3. Question 3 on piecewise functions now. So this is now piecewise function together with mixed with calculus. So x is equals to yes over x. Here we have a 1. So x is not equal to 0, but here x is equals to 0. It's just a similar question to the one that we're just from doing. So remember, f of x is equal to 2 things. F of x is equals to sin x over x. F of x is equals to 1. So f of x is equals to what we have there, which is sin x over x. And the other one, f of x is equals to 1. So what do we do with this guy? We have to find its limit. So we have to say the limit as x approaches 0 of the function sin x over x. So based on what we have there, sin x over x, what does it mean? It simply means that when we replace x with 0, we get a 0. When we replace x with 0, we get a 0. So the result will be a 0 over 0. Sine 0 is 0. Replace x with 0, still get a 0. Is that okay? So after that, this is what will happen. If you get a result of 0 over 0, 0 over 0, you have to use what is known as, so applying the L'Hopital's rule. Applying L'Hopital's rule, not hospital, it's L'Hopital. When do we apply this guy? We apply this guy that for you to be able to differentiate this, or rather to find the limit, you have to say, get the derivative of sine. So differentiate sine, what we get? Cos. As x approaches 0. Differentiate x, what we get? 1. The derivative of x is 1. So after you differentiate both numerator and denominator, we have cos x over 1. Let's apply the limit now. What is cos x? What is cos x? So as in cos 0. Cos 0 is what? 1, isn't it? So it will be 1 over 1. 1 over 1 is the same as what? 1, which is this value that we have here. So because these two are the same, the conclusion is that it is continuous. As simple as that. So about trig functions, this is what you need to know. If y is a sine, then the derivative is a cos. If y is a cos, then the derivative is a negative sine. This is how it works. If you have y, if you have sine, differentiate it, you get a cos. If you have cos, differentiate it, you get negative sine. Just like that. Yes. It's not hospital. No, for this rule, the idea is this. As long as you have 0 over 0, is that okay? As long as you have 0 over 0, then you are allowed to use hospital. Now, according to hospital, we are saying that just differentiate. So, sine, differentiate it. Now, remember, differentiating sine, what do we get? Cos. So, sine changes to cos. Differentiating 1, what do we get? Sorry, differentiating x, what do we get? 1. So that's the process of the L'Hopital's rule. As long as you have 0 over 0 as your result, just substitute the 2 by differentiating what you have. Not cos x, it's cos 0 because it's approaching 0. So cos 0 is 1 over this one, which is just 1. Let's take another example on the same, on the L'Hopital's rule. Let's do question 1 part D. The same? Okay. So that question on question D now is the limit as x approaches 0. We have 1 minus cos x divided by x sine x, like this. So, before you even think of using L'Hopital, you have to try it out. So by trying it out, we mean where there's x, put 0. Everywhere there's x, what do we get? Put 0 where there's x. Remember, we put 0 here, what do we get? 1. 1 minus 1, 0. Put 0 here, everything just 0. So 0 over 0. So as long as you have 0 over 0, then you are supposed to use this guy. Let's apply him. So using L'Hopital's rule, now you have to remember something that we talked about earlier. Because, okay, it will come. So limit as x approaches 0. Numerator, what's the derivative? So remember, derivative of 1 is just a 0. What's the derivative of a cos? Cos changes to what? Negative sign. So you have this negative and the negative sign that will come with it. So the derivative of cos is a negative sign divided by, here what's the derivative? The two functions are multiplying. What does that mean? Product rule. As long as two functions are multiplying, product rule, always. Now, you might want to ask to say, these two functions are dividing, then we use quotient rule. No, the idea is, L'Hopital, according to the L'Hopital's rule, you have to differentiate them separately. Differentiate the numerator alone, differentiate the denominator alone. Now, in the process of differentiating the denominator, we see that the two functions are multiplying. So since they're multiplying, we use product. What does the product say? The first function is u. The second function is v, like this. What's the derivative of x? 1. What's the derivative of sine? Cos. Is that okay? Then this will mean that the formula is uv prime plus vu prime, something like that. So what is our u? X. What is our v prime? Cos. Cos. What is our v? Sine. Then what is our u prime? 1. I won't write it. So this is what we get when we differentiate this. We put it here. X cos x plus sine x. Like that. Now, we have differentiated by using L'Hopital. So go ahead. Find the limits now. Find the limits. What are the limits? What are you getting? Come again? You are lying. 0 over 0, isn't it? How do you find 1?
Just like negative and negative.
Yes.
Signing and 0. And the signing
No. Sine x will be sine 0. So sine 0 is 0.
Yeah. So I cancel the.
No, you can't. This and this. No. That is wrong mathematics. It's not possible. 0 over 0. So this will give you a 0, this will give you a 0, this will give you a 0. So everything will just result to a 0 over 0. What do we do? Yes, my friend, help us. What do we do? The answer is on the board. Tell me, what do we do? Just say hospital. It's fine, just say hospital. We have to use the same L'Hopital again. Understand this, you can use L'Hopital as many as 4 times. As long as the result is 0 over 0, you should always think of the same guy. Now, L'Hopital is not, there's nothing special about this L'Hopital guy. The only thing you need to know is that for you to apply L'Hopital, you have to differentiate whatever you have on top, you differentiate whatever you have here. So since the result of what we're getting here again is 0 over 0, let's apply L'Hopital. So this is what we get. Limit as x approaches 0. What's the negative, negative, positive? What's the derivative of sine? We know that it's a cos, right? Over, what's the derivative here? It's x cos x. The two functions are multiplying. So what do? Product. What's the first function? X. What's the second function? Cos. As long as two functions are multiplying and you want to differentiate, you have to use the product rule. So what's the derivative here? 1. What's the derivative of cos? Negative sine. Okay. Now the formula is still the same one, which is u v prime plus v u prime. So what is u? X. What is v prime? Negative sine. Let's just say, let's put a negative here. Like this. What is v? Cos. What is u prime? It's just a 1. So this is the derivative of these two. Let's put them. So we get negative x sine x plus cos x. Remember, we still have this sign, we didn't differentiate it. This is just the result of the product of these two, is what we get. The derivative of this sign is what? Cos. Like that. So what happens? These two are like terms. So we have the limit as x approaches 0. We have cos x over negative x sine x plus 2 cos x. Is that okay? There are two of them, so 2 cos x. Now let's apply the limit. We see if we get what we want. Where there's x, let's put a 0. We'll have cos 0. If we put a 0 here, this whole thing will just be a 0. So 0 plus 2 cos 0. Cos 0 is 1. Cos 0 is 1. 1 times 2 is a 2. So our answer is half. 1 over 2. As simple as that. If we had found that the result at this point is still 0 over 0, L'Hopital again, until we find something which is not 0 over 0. That's how it works. Any questions on that one? Okay. Any other question you'd like us to go through? Or maybe you people are tired. We need to do an example on the quotient rule. Let's do an example on the quotient rule. On the chain rule, sorry. Chain rule. So differential calculus question 3. Differential calculus question 3, 3a. The question is y is equals to 3x power 3 plus 2x squared minus 4x plus 7. Okay. Remember I said as long as you have a bracket with a certain power outside the bracket, you have to use the chain rule. Now the chain rule works like this. Everything inside the bracket is u. So let u be equal to everything inside, which is 3x power 3 plus 2x squared minus 4x plus 7. Let u be everything inside the bracket. So since this whole thing is u, then what is y? Y will be equals to u to the power 6. Because the whole thing is just u. That's why I'm saying u to the power 6. For this part, we're going to differentiate u with respect to x. So 3 times 3, 9. From x, subtract 1, 2. 2 times 2, 4. From x, subtract 1, just power 1. 1 times 4, 4. From x, subtract 1, 1 minus 1, 0. So to just be 4. Derivative of a constant, 0. No need of the 4. Sorry, of the 7. This side, differentiate y with respect to u. So it will be 6u raised to the power 5. That's the derivative. Is what I've done okay? Step number 1, I said, let everything inside be equals to u, meaning that to be y is equals to u to the power 6, which is what we have there. Then du dx. So that is 9, that 4, this is just 4, this is a constant, so it's a 0, don't even write it. Differentiate there, the 6 goes there, subtract 1 from the 6, get a 5. So the formula for the chain rule is dy dx, I think I gave you this formula, is equals to dy du multiplied by du dx. This is the formula for the chain rule. Let's do the substitutions. What is dy du? Dy du is this guy here, which is 6u power 5. What is du dx? This one, which is 9x squared plus 4x minus 4. Okay, we'll combine the two, we'll get 9x squared plus 4x minus 4, u to the power 5. I'll just put the u that side. Then your final step, you just bring back u. Just replace u. Remember, u is this whole thing. So just replace u. So what do you get? 6, open bracket, 9x squared plus 4x minus 4. What is u? U is 3x power 3 plus 2x squared minus 4x plus 7. Raised to the power 5. So that's your answer. Any questions on that one? Now, when you have trig functions, you have to use the chain rule again. I'll use the same example. We're still on the same question, question 3. Okay, so question 3, the one which has the trig function, you see, have y is equals to 2 cos 3x squared plus 5. How do we differentiate this? We use the same chain rule. Remember, for this one, we had a bracket, we said everything inside the bracket is u. Same thing. Whatever is inside the bracket is u. So you say, let u be equals to everything inside the bracket, which is 3x squared plus 5. Then what is y? Y will now be equals to 2 cos u. Same thing. Put u there, you have y is equals to u to the power 6. So this whole thing has just been replaced with what? With u. So what is du dx? What is du dx? 6x. Remember, we subtract 1 there, so it's just power 1. 5 is a constant. Derivative of a constant, 0. Then what is dy du? Dy du will be negative 2 sine u. Why is it negative? Remember, cos changes to negative sign. So this cos that you see here will change to a negative sign. So negative sine u. Then just combine them by this formula. So dy dx is equals to dy du dx. What is dy du? Negative 2 sine u. What is du dx? 6x. So combine the two. 6 times 2, negative 12x sine u. Remember, in the final step, we brought back u. So same thing. The final step will bring back u. So final answer, negative 12x sine, where there's u, 3x squared plus 5. That's it. That's your answer. Welcome late. We're even done.